Let's take a look at the geometry of molecules when we have four groups around the central atom. Molecules like CH4. For all of these examples, I've already figured out how many electrons. You can do this by yourself. That's not the most difficult part of these problems. Once again, what you have the least amount of, that's going to be the central atom. So I have one carbon to four hydrogens. Therefore, I'm going to bond my carbon to my hydrogens. Okay, and now let's count the electrons around. 2, 4, 6, 8. I've used all my 8 electrons. My carbon is happy. My hydrogens are happy. Now, when I have four groups like this around the central atom, and 4 atoms around, so I have 4 groups, but I also have 4 atoms around the central atom. That means the electron pair geometry and the molecular geometry are the same. So electron pair geometry in this case is the same as the molecular geometry, and this is called a tetrahedral geometry. Remember, the only time when the electron pair geometry and the molecular geometry are the same is when you have the same number of groups and the same number of atoms around the central atom. So here I have 4 bonding groups, but I also have 4 hydrogens, 4 atoms that bond to that central carbon, which means that both of these are the same and they're a tetrahedral geometry. The angles are about 109.5 because I take, once again, 360 and I divide it by 4 this time. Now let's take a look at what happens when we have one less atom bonded to that central atom. Nitrogen is my central atom in this case and is bonded to the 3 hydrogens. Now the hydrogens are happy. They have their 2, and nitrogen has 2, 4, 6 around it, but I have to use 8. That means that nitrogen has to have that lone pair over here. Now what have I done? I still have 4 groups around the central atom, which means that the electron pair geometry, it's still tetrahedral, because the electron pair geometry doesn't care about what is around the central atom, as long as it just counts the number of groups around the central atom. So electron pair geometry is tetrahedral. However, the molecular geometry has changed a little bit now because I've replaced one of these atoms with a lone pair. So I have 3 hydrogens, so 3 atoms and a lone pair around that central atom. This lone pair pushes down on each of these bonds, so they're not quite at 109.5 degrees anymore. They're not all angles are not quite equal because this lone pair takes up a little more room than just an atom would if it were an atom. That means that I don't have a tetrahedral molecular geometry anymore. The molecular geometry for this particular molecule is called trigonal pyramidal or pyramidal. If you get stuck, just like we had trigonal planar, where we had 3 groups around, where we had just all of them in a plane of a triangle, here this is trigonal pyramidal, where you think of the nitrogen being on top of a pyramid with each hydrogen at the corners of that pyramid with a triangular base. So if this is a pyramid, then I have a trigonal pyramidal type of molecular geometry. Remember, the electron pair geometry is still tetrahedral because it doesn't care what I have around, it just cares about the number. The number didn't change. I still have 4 groups around the central atom, so the electron pair geometry is tetrahedral because that's what the 4 groups relate equal tetrahedral geometry, But the molecular geometry changes because now I've replaced that one of the atoms with a lone pair, and it makes it into trigonal pyramidal. Let's look at the last example where we have water. My oxygen is bonded to each hydrogen. The hydrogens are happy, but I've only used 4 electrons. And now I put the other 4 electrons as lone pair on the oxygen. Now let's take a look. Once again, I have 4 groups around my central atom. So the electron pair geometry, once again, has not changed. That is still tetrahedral because I have 4 groups around. That's all it cares about. I have 4 groups. Now, when we look at the molecular geometry, we'll look at the types of groups. Okay, I have only 2 atoms this time, and I've replaced 2 of the atoms with 2 lone pairs. And remember, we said the lone pairs will push really far from each other, so they'll really push those hydrogens closer together because they take up more room than if I just had hydrogens over here. And therefore, we don't have a trigonal pyramidal type of geometry anymore. The molecular geometry for these kinds of molecules becomes just bent. So these are the steps that you need to follow when you're trying to figure out the electron pair geometry and the molecular geometry. Note that all of these molecules still have the same electron pair geometry, which is tetrahedral because they have 4 groups around the central atom, but they differ in the molecular geometry because for CH4, these 2 were the same because I had 4 atoms around the carbon. Here, this becomes trigonal pyramidal because I've replaced one of the hydrogens with a lone pair. And then finally for water, I've replaced 2 atoms with 2 lone pairs, which will really push those bonds, those OH bonds, even closer together, making it a bent molecule. Okay, this is the end of the slides for chapter 4.